everyone, welcome back to my channel. Hope you are all fine, good, doing good in your life. Today we are going to discuss the part 2 video of the splicing pathway. As we have discussed previously, what is splicing, why does it takes place, and what after which mechanism does the splicing takes place. So I am going to make a quick review what is splicing. Basically what happens after the transcription process, the mRNA which is formed or the RNA basically which is formed is of primary. You can say it is non-functional. To cut out the unnecessary part which is does not take part in the protein synthesis, we do this process, that is splicing, that is removal. Okay, to chop out or to cut out the introns from the segment of RNA. In the previous video, we have discussed the first pathway of splicing, that is spliceosomal pathway. So if you have not watched that part, I do recommend you to please go to the previous video in my molecular biology playlist and do check out this spliceosomal pathway. And also have given the introduction about introns, what is introns, what is exons. I'm not going to repeat it once again. So if you are genuinely new to my channel or you are starting the video from here, I recommend you to go back to that video and watch, and then you can watch this video. So let's proceed. So first, in the second part, we will be seeing about the second type of splicing mechanism, that is self-splicing mechanism. Before introducing or before going to the mechanism part, let me first tell you what do you mean by self-splicing. The common meaning, you can say that the process is done by itself. It does not require the help of any other mechanism or any other protein to help out in the splicing pathway. As we have seen in the spliceosomal pathway, that special type of snRNP or special type of proteins were required for the splicing. But in this case, the cell splicing case, here the splicing takes place by itself only. It does not require the help of any other protein. That's why it is called splicing path, self-splicing path. So now we are going to move forward about what is self-splicing pathway. So let's start. So what do you mean by self-splicing? I have already introduced you and I have discussed about it. This self-splicing is again divided into two main categories. One is group 1 intron and what is group 2 intron. Must be wondering what is group 1 intron and what is group 2 intron. But let me make you understand that what is group 1 intron. So first we will go to the mechanism part. As I have already told you the basic structure of the intron. What is the basic structure of the intron? That is, it have a 5' exon. Wait, let me do one thing. So it have a 5' exon. Okay, 5' exon. I'm talking about the basic structure of the mRNA. It has 5' exon side, 3' exon side, and the middle part, this whole total part which you are seeing is the intron part. And in the intron part, if you remember that it has a 5' splice side, this site is known as the 5' splice side, and this part is known as the 3' splice side, and in the middle there will be a branching point. These are the three basic things which are required for the splicing. First is the 5', that is the donor side, 3' that is the acceptor side, and middle is the branch point. These three are required for the branching or for the splicing purpose. So what happens in the group 1 self splicing? This 3' end, okay, this 3' splice site will make a nucleophilic attack on the 5' splice site. You can see this guanine which is present on the 3' splice site will make a nucleophilic. You can see the arrow coming towards this 5' splice site. So these guanine will make a nucleophilic attack on this 5' splice. As a result, what will happen? This 5', this region will now get detached from it. This 5', this region of the intron will get detached from the 5' exon. Now what will happen? This region will be free or will be of OH, that is 3' OH region. This region is known as the 3' OH region. Okay, this region is known as the 3' OH region, because now what happened, this region was separated because of the nucleophilic attack, and now it formed a 3' OH end. Now what will happen, these 3' OH end will again do a nucleophilic attack on these 3' splice side. As you know, this is the 3' splice side, it will again do a nucleophilic attack. As a result, what happened, this set, that is this complete intron will be removed out, and now the exon, that is the 5' and the 3' exon will be joined out, and the intron is removed. And one more thing about this intron, the intron which is formed is of the linear shape. Okay, the intron which is released out is of linear means straight line, it is of linear shape. And now the splicing is completed, that is the 5' and the 3' end is now joined. So now you have been understood that what happened actually. Here no protein bind, there was no binding of protein, nothing. Only the 3' splice side itself make a nucleophilic attack on the 5'. As a result, the 3' OH end was created on the 5' exon, and this again, this 3' OH end made another nucleophilic attack. As a result, the intron was removed and the exons joined. So by this mechanism, you might be clear that why it is called self-splicing, because no other intermediary molecules was required for this removing the intron. It itself was capable enough to remove the intron. That's why it is called self-splicing group 1 intron. Okay, that is why it is called group 1, because of the first category of how the self-splicing takes place. That's why it is called group 1 intron. Nothing more than that. Next, moving to the second part of the that is self-splicing, that is group 2 intron. It is another type of self-splicing mechanism, and here it is a bit different from that which we have discussed previously. What did be different? You might be knowing the basic structure of the mRNA, that is 5' exon, then 3' exon. Middle part is known as the intron region. Intron has the 5' splice site. Here it is 3' splice site, and middle has the branch point which was adenosine rich. You might be in this part, if you want to make it clear, you can watch the previous video and get it basically clear that what is the mRNA, what is the structure, basic structure of the mRNA. Okay, moving to this part, what happened, this adenosine which is the branch point have the 2' OH end. Okay, have the 2' side. These 2' OH will make a nucleophilic attack on the 5' splice side. Okay, now the rest of the process will be similar to the group 1. Okay, now what will happen, this 5' exon will have a 3' OH end, free end. Now this intron is removed, detached from it, and it will form a lariat. And these, what do you mean by lariat? Lariat means a rope-like structure. You can see this is a rope-like structure. This, from here it is detached. Now this overhanging region will make a joining to that of the branch point. Now you can see here how it is formed. It is like a loop-like structure or a rope-like structure. The intron is present, and here the 3' OH will be formed. Now again this 3' OH, you can see this, that is the arrow is pointing towards the 3' splice site. So now what will happen, this 3' OH will make a nucleophilic attack on the 3' splice site. Now this intron will be removed out, okay, completely, and then the exons are joined, that is the 5' and the 3' exons will be joined. What you have seen, the difference between the group 1 and group 2 is that in the group 1, that is the 3' splice site was making a nucleophilic attack, but in the group 2, the adenosine, that is in the branch point 2' OH end, was making a, that is a nucleophilic attack. Second difference is that the intron which is formed in the group 1 is of linear shape, whereas in this case, that is in the group 2 intron, that is the intron which is formed is of the lariat or a rope like. Okay, so this is the basic difference between the group 1 intron and the group 2 intron. But the mechanism is same, that is they are performing the splicing mechanism by their own. They do not require the help of any other additional protein as we have seen in the spliceosomal pathway to perform their action. So by this you must be clear about what is self-splicing. So this is the part 2 video which I was discussing, and with this we come to the end of what is self-splicing and what are the two mechanisms. In the next part we will be discussing about the third part and the last part of the self-splicing mechanism, splicing mechanism, that is the tRNA splicing. I want to give you just a quick review that the tRNA splicing will be completely different from these two. Okay, so the spliceosomal and the self-splicing pathway, this two mechanism is somewhat similar, like the intron making of nucleophilic attack, removal of intron, joining of exon, all that thing was quite somewhat similar except the protein part. But tRNA splicing will be completely different from that. So stay tuned for the next part of the video. For that you need to like, share and comment. If you have any doubt regarding this video, you can comment in the comment section and share among your friends as much as you can. And if you are new to my channel, do subscribe, and thank you and have a nice day. See you soon.